Good day everyone. Welcome to today's edition of our mathematics presentation. Okay, the topics that we are going to discuss today, Mathematics 5, Quarter 1, Module 6, Finding Common Factors, GCF, using listing method, and factorization. Okay, it is expected that after going through this module, you are expected to find the factors of the given numbers. Number 2, you will be able to identify the common factors of a given numbers. Number 3, find the greatest common factor of a given numbers using listing method, prime factorization, and continuous division. Number 4, identify the greatest common factor of a given numbers. Number 5, use divisibility rules in finding the greatest common factors of the given numbers. Okay, let us first define the following terms within this module. We have factors. What do we mean by factors? These are numbers that we multiply together to get another number. For example, 2 and 4 are factors of 8. So when you have to find for the factors of 8, you have to multiply 2 times 4 and you will get 8. Another one, you have 3 and 5 are factors of 15. So that if you are asked what are the factors of 15, so the numbers are 3 and 5. So we call this factors. Okay, next we have common factors. So what is these common factors? These are numbers used as a factor of 2 or more numbers. Example, 1, 2, and 4 are common factors of 4 and 8. It's because 4 has a factors of 1 times 4, 2 times 2. So these numbers are being used as a factors of 4. Now, this number also are all factors of 8. Because when you are to get the factors of 8, you will have 2 times 4. So these three numbers are common factors of 8. Meaning to say, these are used in getting the numbers of 8 and 4. So they are called common factors. Next one, we have prime numbers. What do you mean by prime numbers? Prime numbers are numbers whose factor is only 1 multiplied by itself. What does it mean? Meaning, these numbers, the factors of these numbers is only 1 multiplied by itself. For example, you have 2. What are the factors of 2? We have only 1. You have 2 times 1, meaning the number multiplied by itself. And 1 multiplied by itself. If the number is 2, then we have 1 times 2. And you have another one, we have 3. Factors of 3 is only 1 times 3. So 1 multiplied by itself. Okay. So we have 5. There is no other factors of 5 except 1 times 5. We have 7. So 7 has no other factor except 1 times 7. Next one, you have 11. 11 has no other factors except 1 times 11. So these are called prime numbers because this number has only one factor. We have 1 multiplied by itself. Okay, we will now discuss about prime factorization. Now, talking about prime factorization, we will be getting the factors of a particular number doing the prime factorization. So, what is prime factorization? Let us going to look for the prime factors of a particular number. So we have example number 1, we have 12. So first we are going to get the factors of 12. So factors of 12 is 1 and 12. 1 multiply by 12 will give us 12. So that is the first factor. Going into the next factor, because 12 is not yet a prime number, so we will get the factors of 12. So we will have 2 and 6. So 6 is not yet a prime number, so we will still factor 6. What are the factors of 6? We have 2 and 3. So we were not able to get the prime factors. We have 1, we have 2, another 2, and 3. So these are the prime factors of 12. So that if we multiply these prime factors, we have 1 times 2 equals 2, times 2 we have 4, times 3 we have 12. So multiplying both the prime factors of a particular number, particularly 12, will also get 12 if we are going to multiply the prime factors. So this is how prime factorization is being derived. This is called the factorization tree, doing the prime factorization. So let's go into example number 2. We have 16. So what are the factors of 16? We have 1 times 16. So 16 is not a prime number, so we will still have to factor this one. 16 has a factors of 2 and 8. So 8 is not yet in the prime number, so we still have to factor 8. So factors of 8, you have 2 times 4, or 2 and 4. So 4 is not yet a prime number, so we still have to factor 4. So we have 2 times 2. These are the factors of 4. So we were not able to come up with the prime factors of the numbers. So we have 1, and we have, how many 2 do we have? We have 4. So that all these prime numbers will be multiplied to check whether we will be able to get 16. So 1 times 2, we have 2, times 2, 4, times 2, 8, times 2, 16. So these are now the prime factors of 16. Okay, so that when we talk of factors of a number, we are talking about the two numbers where when we multiply them, it will give another number. So we have 8 has a factors of 1 times 8, 2 times 4. So 12 has a factor of 1 times 12, 2 times 6, and 3 times 4. So we call these numbers factors. So when these numbers will be multiplied, it will give us another number. So every number, as long as it is a composite number, has a factor, whether it has 2 or more factors. Okay, let's have examples of common factors. So for numbers 8, 12, and 20, we will look into the common factors of these three numbers. So for 8, we have factors of 1 times 8, 2 times 4. So these are the factors of 8. So about 12? Factors of 12 is 1 times 12, 2 times 6, and 3 times 4. And we have also the factors of 20, 1 times 20, 2 times 10, and 4 times 5. So if we were to look at the common factors of the three numbers, we have 1. So all these numbers have a factors of 1. Another factors is we have 2. So all these numbers use a common factor of 2. So another one is you have 4. They have 4 as their common factors. So these numbers are what we call common factors. These numbers are used by both 8, 12, and 20 as their factors. So we call them common factors because these numbers are common to the three numbers. They are being used as a factor in getting 8, in getting 12, in getting 20. Okay, we have next example. 6, 9, and 15. So we will try to look into their factors. Factors of 6, you have 1 times 6 and 2 times 3. Factors of 9, we have 1 times 9 and 3 times 3. Factors of 15, we have 1 times 15 and 3 times 5. So these are their factors. So if we are to look at the number 1, number 1 is being used when we are to get the factors of 6, factors of 9, and factors of 15. So we have also another factors, common factors. We have 3. So 1 and 3 are common factors of 6, 9, and 15. Why do we call them common factors? Because they are being used in getting number 6 and number 9 and number 15. So they are common to the three numbers. Okay, let us now discuss about the greatest common factor, or we have GCF. Now, what do you mean by GCF? Greatest common factor. Now, GCF is the greatest or the biggest number that can divide two or more numbers exactly without remainder. Therefore, if you are asked about the GCF of two or more numbers, then you have to see to it that you are able to choose the greatest common factor. Now, how to get the greatest common factor? Of course, first you are going to get the factors of the numbers. So, example, you have 12 and 8. So, to get their common or greatest common factor, we have to first get their factors so that we can look at the greatest common factors. So, factors of 12, we have 1 times 12, 2 times 6, and 3 times 4. Then you will get the factors of 8, we have 1 times 8, 2 times 4. So, looking at their factors, we have 2 also, common factors. But since we are looking for the greatest or the biggest number, so we will choose 4. So we have only 2 and 4 as their common factors, and we have 4 only as the greatest common factor. Okay, let's have another example in getting the greatest common factors of 2 or more numbers. So numbers are 24 and 18. So to get the greatest common factor, first we are going to get the factors of each number. So first we will get the factors of 24. So we have 1 times 24, 2 times 12, 3 times 8, and 4 times 6. And we will get also the factors of 18. 1 times 18, 2 times 9, and 3 times 6. Now, looking at their common factors, you have 3 as one of the common factors. You have also 1. And the last one, you have 6. So, although they have common factors of 1, 2, and 3, but since we are looking for the greatest common factor, so we will choose 6 because 6 is the greatest common factors of 24 and 18. Okay, we will have another example. So this time we will have 3 numbers. So we will get the greatest common factors of 3 numbers. Again, first step that you are going to do is you will get the factors of the 3 numbers. You will have the factors of 8 first. So factors of 8, you have 1 times 8 and 2 times 4. So you will get the factors of 20 this time. We have 1 times 20, 2 times 10, and 4 times 5. So for the factors of 32, we have 1 times 32, 2 times 16, and we have 4 times 8. So these are now their factors. Now we will now look into their common factors. They have the common factors of 1, common factors of 2, and common factors of 4. Now, since we are looking for the greatest common factor, so we will choose 4 because 4 is the greatest common factors of the 3 numbers. And 4 can divide exactly 20, 32, and 8. So, we have this as our greatest common factor. Okay, now I am going to introduce to you another method of getting your greatest common factor. Okay, this time this is shorter than the other method. So you will have to choose which method are you going to use when you are to find for the greatest common factor. Okay, first that you are going to do is you are to look at the smaller number. So your smaller number is 16. So you try to look at the two numbers. Can you divide the two numbers by 16? Of course, you could not divide 24 by 16. You can divide 32 but not 24. So what you are going to do is you are going to divide the smaller number by 2. So as you divide smaller number by 2, which is 16 divided by 2, you will get 8. Now 8 is the result, and 8, and you can divide 24 by 8. You can divide 32 by 8. So you will now use 8 as your GCF because 8 can divide 16, can divide 24, and can divide 32 exactly without remainder. So you were able to obtain 8 by simply dividing the smaller number. So first step is look at your smaller number, and if your smaller number cannot divide the second and the third number, then you start dividing it by 2. So we divide 16 by 2, we have 8 as the result. And 8 can divide 24 exactly. Can also divide 32 exactly without remainder. So 8 will now become our GCF. Okay, let's go to the second example. 12, 16, and 20. Again, the first step that you are going to do is look at the smaller number. The smaller number is 12. So, if we are to look at the second number and the third number, we cannot divide 16 by 12. So much as 20 cannot be divided by 12. So, the first thing that we are going to do is we will divide 12 by 2. So, result is 6. 6 can divide 12 but cannot divide 16 and 20. So we will go to the next step. We will have 12 divided by 3. 12 divided by 3 will give us 4. So result is 4. So we will try to divide 16 by 4. So we can divide 16 by 4 by simply getting the divisibility of 16. So we have 20 can be divided by 4 also. So by that method, we were able to get the greatest common factor by just simply using the steps that I have introduced to you. First, divide the smaller number by 2. If the result is not could not divide the three numbers, then you will go to the next step. Divide the smaller number by 3 until you will find the least or the greatest common factor. Okay, let's have another example on how to find for the greatest common factors of two or more numbers. Okay, this time we have three numbers and we are to find for the greatest common factors. Okay, so 8, 24, and 40. So as what I have told you, when you are doing the method that I am introducing, first thing that you are going to do is look at the smaller number. So the smaller number is 8. Now, look at the second and third number. Can you divide 24 by 8? Yes, you can divide 24 by 8. Can you divide 40 by 8? Yes, you can divide 40 by 8. And you can determine the divisibility of 24 and 40 by looking into the role in the role of divisibility of numbers of number 8. Huh? Numbers is divisible by 8 if the last two digits are divisible by 8. So 24, the last two digits of that number, you have only two digits. So it is divisible by 8. 40 is also divisible by 8. So we will simply use 8 as our greatest common factor. So we were able to get the greatest common factors of the three numbers by simply applying the rule of divisibility. Okay, let's have Next example, 6, 18, and 30. So, 6, 18, and 30. So, what is the smaller number? So, we have 6 as the smaller number. Again, we will apply the rule of divisibility of numbers. So, since our smaller number is 6, we will look into the second and third number, which is 18 and 30, if it is divisible by 6. So, applying the rule of divisibility of 6. What is the rule of divisibility of 6? The rule says, if the number is divisible by 2 and divisible by 3, then it is also divisible by 6. 18 is divisible by 2. 18 is also divisible by 3. 30 is divisible by 2 and also divisible by 3. Therefore, it is divisible by 6. So, we will use 6 as our greatest common factor. Okay, this is all for today's video. To all my subscribers and for those who are new to my channel, thank you for watching. Don't forget to share, like, and subscribe my channel so that you will be notified for the next videos that I will be uploading. Once again, thank you and God bless.